Lasers are no longer part of the future. They are part of us. They are today. They are available, and we know how to crack it to bring them and field them into the battlefield.
Welcome to the first episode in our special two-part podcast series with Rafael. In this conversation, we're focusing on directed energy, and in particular, high-energy laser systems. Once the stuff is science fiction, these systems are now becoming a real part of layered air defense strategies around the world. I'm joined by Gideon Weiss, Vice President of Business Development and Marketing at Rafael, and Dr. R, who's a Senior Systems Engineer behind the company's laser systems out of Rafael's Land and Naval Systems Division. We'll unpack what's driving the laser revolution, what makes Rafael's technology different, and how this capability is reshaping modern air defense. Gideon, first of all, before we get into the story of laser technology, we're just weeks away from the Paris Air Show, and I guess I'm curious what the company will be showcasing at the event itself.
Well, hi, Tony. Great to be on your podcast. Yeah, so on the Paris Air Show, we will actually have the full gamut of systems, but we will highlight the three main things that we believe are the most important. Number one is high-energy lasers. Number two is multi-layered air defense systems, which we're going to show some very interesting things, including some new innovations. And, of course, long-range precision strike. These three main items are going to be at the highlight of our booth and of our display. Other than that, we're absolutely going to show and talk with customers and partners about the suites of the entire suites of systems for fighter jets, space and intelligence systems, counter UAS, and other systems that we will be having there. Of course, the Spike, the famous Spike. In the air show, most of the interest is about helicopters, but it's a whole family of systems. So all of these systems will be on display, and we'll have a lot of meetings in that realm. But the three items on highlight are, as I said, high-energy lasers would be number one, multi-layered air defense, and long-range precision strike.
So those conversations around high-energy lasers will be happening during the Paris Air Show. So let's kind of dive into the story. I mean, in terms of the broader context, what's driving the demands for laser weapon systems today?
Yeah, I think what we want to look at is the global trends. There is a great deal of evolution in the threat environments. We're looking at the war in Ukraine and the wars in the Middle East that unfortunately we had to burden. And there are multiple threats here that we're seeing all around. Even recently between India and Pakistan, we've seen drones and UAVs. Some of them are coming in swarms. Of course, a lot of rockets in various types. And so when you think about how to defend against those, this is not just about air defense, the classic air defense and interceptors. The cost-driven considerations really bear the cost of the interception that by kinetic interception that call for the lasers to augment that and to reduce the overall cost of interception. There's emphasis on precision and speed and cost effectiveness. So when you talk about cost effectiveness, if there's a way to collaborate between laser systems, high energy laser systems, as interceptors, as effectors in the air defense realm, so you can save a lot and mitigate these threats not only by kinetic but also by lasers. This is generally that. It's looking at trends and what customers need, and certainly there's no nation on earth that can claim that they do not have this type of threats, because as conflicts emerge, clearly your enemies are going to look for the cheap and easy way to get around it, and UAVs and drones and rockets are very, very easy for them to get hold of.
And Dr. R, just moving to you, and I guess before we dive too deep into the technology itself, and admittedly this might be a difficult question to answer, but is it possible to explain in simple terms what a laser weapon system actually is?
Absolutely. I'll do my best. Let's get a short tour back to 1960 when the laser was invented. A couple of years later, people start looking into multitude of applications, from medical surgery, material processing, and even laser shows, and obviously the military applications as well. What people figured out during 50 years of a lot of successes and multitude of failures trying to implement the laser technology for practical applications was an empirical rule that says that if you can do it without lasers, do it without lasers, which means that lasers almost never could replace the existing technologies, but they found their place as enabling technology for new novel applications. That happened with the material processing when they didn't remove the conventional machinery, but they enabled new applications when the precision, material quality are something that cannot be achieved without the lasers. For military applications, it's closely related to material processing. When you can cut a metal, obviously the general idea was that if you can do that with the machinery at a centimeter distance, you can probably do that at kilometer distance as well. So you can, if you have a threat, you have a ballistic missile, you can hit it with a laser, cut it through, get to the explosive, heat it up, and eventually the threat will explode. So material processing and military applications are closely connected. What happened during decades of development, that there were multitude of demonstrators and all kind of lasers, all kind of technologies that had been developed and demonstrated, but no practical system went out of that for the reasons that I will explain later. There is an inherent limitation for lasers regarding range and their effectiveness against certain threats. And that's something that we could solve during recent years, and that basically the technology that enabled to put Rafael lasers into the battlefield.
Excellent. That's a good summary. And Gideon, you've touched on this already, but there are a multitude of threats out there. What makes lasers so well suited to countering a lot of these threats?
Well, I believe when you look at the conflict in Ukraine, but especially those who paid attention to what was going on in the last 18 months from October the 7th in the region, in our region in Israel, both rockets that we had to endure from Gaza as well as from Lebanon, they came in thousands and thousands. And when you think about, for every rocket that comes in that is well aimed at a populated area or at a strategic area that you want to defend against, then if you send an interceptor against each and every one of them, even if you shoot all of them out of the sky, you would still have a lot of debris coming down. And so it's two things that are driving the laser development in the need area. Number one is the need to be more effective and have less debris or less fallout from these interceptions, and in many cases we will be able to catch or shoot down some of the threats even early on as they emerge. But the most important thing is the economy of interception. Think about the fact that when you shoot out an interceptor, it doesn't matter which type of interceptor you're shooting, it's a missile. And a missile is always expensive. The European and American missiles are way more expensive than ours, but even our missiles are still considered to be a burden on economy when you think about how many of those we need to shoot out. But once we have completed the development of the laser system, then an interception by a laser system is magazine free. It's always abundant, and you can shoot as many times as you want because it's just power. And then the cost of interception is just the cost of, let's say, the electricity and the maintenance and the ongoing maintenance. So it's a few dollars per interception. So these are the main drivers: the operational driver and the economy driver.
So Rafael has been in this game for decades, and I guess I'm kind of curious about what some of the core breakthroughs were in terms of these systems being able to move from the laboratory out into the field.
So I want to start with a little bit of history and say where we are at today. before I hand over back to Dr. R. There's a nice story to tell. Number one is that Rafael was already in the business of lasers and high energy development from the mid 90s. We were there with some allied nations, and we did quite a few big projects at the national level and international collaboration. But as Dr. R explained in the early days, those were failed attempts. They showed some capability, but it was unfeasible to field them and build them as serial production for various reasons. But if you want to look at the evolution at Rafael, we kept on doing this. We kept on engineering it. So I am proud to say that I was part of one of the first systems to be fielded in the IDF. That was in 2006, when I actually participated in the fielding, and I was heading the training and qualification of the soldiers and officers that took hold of that system in those early days. This was one of a kind laser system that then was put to operational use. But when you think about the systems that we have today, Rafael has become a powerhouse, really, both in engineering as well as in overall capabilities, including the manufacturing capabilities, a powerhouse for lasers today. Right now in Paris, we will show the light beam, which is a 10 kilowatt class. We'll show the iron beam M, the mobile iron beam, which is a 50 kilowatt class, and the iron beam, the big iron beam, which is a 100 kilowatt class laser. And those, our listeners could look them up and see what they are and look at the brochures. But in general, what I'm saying is that now we have become the powerhouse that can bring these capabilities to the field.
So the laser defense is basically a remote material processing. In order to make that happen, there are two major challenges. The first one is obviously to get the laser power high enough so it will be effective at long ranges. And that's a challenge of physics and technology that is way beyond the power levels available for industrial applications. So to enable that, the general idea was to combine multiple single lasers in what is called coherent way, which means that they are synchronized one with the other, so they are getting to exactly the same point on the target. And that's what is called the coherent beam combining, which is enabling technology to get to high power levels. The second challenge is about physics and nature. It's called atmospheric turbulence. It's the effect that everybody knows from the airplanes, where there are pockets of air with different density and the airplane jumps up and down. Exactly the same thing happens on the small scale, on a millimeter and centimeter scale. And the light beam going through the atmosphere bounces back and forth and distorts its shape and position on the target. So that effect extremely limits the effective range for a laser propagation. Typically, a couple of kilometers is the maximum limit that you can get small enough beam that will be effective for a cutting or a damaging a target. What we found that the coherent combination of single beams allows to control the shape of a beam in such a way that this atmospheric turbulence effect is effectively minimized and eliminated, so we can get to ranges far beyond what is available without that technology. And when we can get to long enough range, the system becomes much more cost effective, and we can get to performance that is needed for a defense with much less power compared to other systems, which again makes that much more practical and cost efficient.
And yeah, I guess we often forget that there's people behind the breakthroughs that you're talking about. And Dr. R, I know you've spent the last 25 years working on this technology. What was your personal experience in terms of getting to where we are today?
When I started my career in Rafael, I started working in the environment that knew a couple of phrases that were in the business. One of them was high power solid state lasers are 3 years away from us for already 2 decades. And the second one was even more insulting. It said that high power lasers are the weapons of the future and always remain as such. For almost 20 years of my career, I found that that's actually true. And I've seen people retiring without putting a single operational system in practice. So I put myself a challenge or a task not to retire without putting a practical system in the battlefield. And we are there. We're getting close to there. And I can say that this challenge was accomplished. And it happened thanks to not a single event, a single Eureka event, but it was a gradual process with a lot of trial and error, a lot of failures and successes of a big team of researchers and engineers for more than a decade and a half, when starting from the general idea that, by the way, was not obvious. It was based on the idea that was known not to work. There were a couple of papers published that were showing that this idea cannot work. Our team of scientists could actually figure out how to twist a little bit that idea and make it work. And that's a pretty unique technology that, to my knowledge, is employed in Rafael in a very unique way compared to anybody else.
Excellent. And let's talk about integration for a second. And I know this will be a question that you'll be asked during the Paris Air Show. Are these laser weapon systems just for Rafael platforms, or is there a broader flexibility there?
I want to say two things. Before I get to integration, I want to say one more thing. I think what Dr. R highlighted about the energy and how we overcome the problems of adaptive optics, I think when you look at the competitors, one of the discriminations is to say that we need such and such power over the target in order to eliminate the target. And that is always true. That's physics. But when you want to get to a certain level of power over the target, you may use a very large laser and say, I'll just put a lot of power out there and get that power in, even though I lose a lot of the power on the way. And what Rafael is doing, what Dr. R has explained, is that our optics are so adaptive and so effective that we can live with much lower laser source because we can get the same amount of effective energy onto the target. And I think that's the major thing in our ability to come forward and say we can be competitive. About your question of integration, I think it behooved Rafael from the beginning, from the get-go, to design the system in such a way that it would be completely agnostic to whichever platform and command and control system it would be connected to. That is a key element for two reasons. One is because from the beginning, we had to think about the Israeli environment, which is not just one problem, but a few systems. So when you think about the need to be able to hook up to Israeli systems, to U.S. systems, to European systems, or whichever other systems that you want to be able to collaborate with, then the open architecture is the key element that enables us to do that. And so when we think about how the lasers will be used in combat, they would usually not be used as a single effector in their place, but they would be used in cohesive environment while integrated into other air defense systems, or at least early warning systems, in which they can be integrated and have or become one of the effectors in that multi-layered defense, if you will.
So without getting into anything classified, obviously, are you able to share any details about whether these laser systems have actually reached the point of operational deployment? Or are we still talking about future integrations?
So I am unable to comment on anything current. I can only say that as earlier advertised by both the IDF and MOD, and as well as by Rafael, we are standing behind our commitment to work with the IDF and the MOD to field the system as early as later this year. And this is under contract with our MOD.
So yeah, that's great context. That's good detail to know. Gideon, we're sort of almost running out of time, but if we were to wrap up this conversation with two key takeaways for our audience, what should defense leaders remember from this conversation?
Well, I think there are, very plainly said, there are two things to remember. Number one, lasers are unlike what we thought to be. If you want to do something, do it without lasers. That's no longer the case. Lasers are no longer part of the future. They are part of us. They are today. They are available, and we know how to crack it to bring them and field them into the battlefield. That's number one. And number two, I think it's a lot about international collaboration, allies joining forces together, and especially the understanding that a laser system will never be standalone, or almost never be standalone, but will be integrated as an effector to a multi-layered air defense system. And that's something that every nation will have to define what the ranges are and what their requirements are and what their threat sets are. But we are working with our partners and collaborating with them both on the requirements and operational level, as well as on the industrial level, in which we have a lot to offer for our industrial teammates and partners.
So I guess, the whole community is aware of the current threat matrix. It's in the news all the time. This has been a really fascinating insight into the role that directed energy and high energy lasers can play in countering a lot of these threats. I'd like to thank our guests. We've been joined by Gideon Weiss, who's Vice President of Business Development and Marketing at Rafael, and then also Dr. R, who works with the company's laser systems out of Rafael's Land and Naval Systems division. If anyone's interested in learning more about the technology, as we've said, the company will be at the Paris Air Show. So come along and see the company then. Gentlemen, thanks for joining us today.
Thank you very much.
Thank you very much.
Don't forget to check out the second episode in this series, where we focus on the evolution of long-range precision strike capabilities, the operational challenges it's designed to meet, and the technologies enabling smarter, faster, more precise targeting. Until then, take care.